Hey everyone, welcome back to my YouTube channel. If you're seeing me for the first time, this is Santosh Pothraju. Today we are in Kafka tutorial. And to be honest, this is a very special topic for me because as I described in earlier video, which is overview of this complete core. Irrespective of our background, the Kafka is going to solve a lot of problems. So in this video, we are going to talk about what is the overview of Kafka and what is the actual problem solving by Kafka. So to illustrate this problem clearly, let's pick one analogy, and based on that analogy, we can understand what is the actual problem solving by the Kafka. So to explain this problem statement, I took a pizza shop as an example because pizza shop analogy is very popular for Kafka problem statement explanation. So let's understand that this is some pizza shop, and back in days when maybe in 2010, the time where small businesses are also adopting the online businesses. Let's assume that this pizza shop also started taking the online orders. So for example, customers have an ability to place the orders using some web application. And let's say customers are place some orders, right? So once they place the orders, those requests must be processed by the some backend application. So this big box right here, let's think like this is our backend application. And out of this big application, let's split into a small component because in in any web application, the task will be split into the small application, right? So here, let's consider we have four small microservices, and these microservices are actually processing actual request coming from the request. So the very first microservice, this could be the payment, because if we need to confirm whether the request successfully landed in our queue or not, that we can confirm with the payment. So once we receive the payment for any order coming from some customer, that means that is a successful order. So for any successful order, the immediate next step should be updating the inventory, because every pizza shop or every grocery store maintaining the appropriate inventory is not only requirement. Okay, so let's say the inventory is also updated. Then after, let's assume that in the workflow, we have another microservice which is going to take care of the notification. And this notification piece is going to take care of dropping all the notifications whenever we have some updates right here. And then after, notification is also sending some notification to chef team. Let's assume that a chef team, they have their own pager type of system where they will receive the order details. Okay, so let's assume this is a very simple workflow. And if you see here, the services are kind of internally dependent, meaning the payment system is going to process the payments. And once payments are processed, and then based on the status, inventory update is going to happen. And then based on this, the notifications will be sent out to the customers, and also notification will drop to the chef team or something like that. So here, let's assume that chef team is also going to have some sort of a dependency with the inventory, because chef team is the actual people who are going to use the ingredients for pizza, right? So let's assume that these folks used some ingredients and that they made some updates on the inventory. So like that, every component is kind of having some sort of dependent. So let's assume that these all are kind of internally dependent. And now the complexity begins right here. So let's assume I have to introduce another component right here. Maybe we can call this as printing service. So this printing service is going to take care of printing the ticket. And whenever we have the payment completed for any new order, this printing service is going to take care of printing the receipts for the customer, or maybe printing the tickets for a chef team. Let's assume that this microservice is going to take care of that piece. So now this microservice has to be integrated with all these services, right? So if you see here, very shortly, by adding another service is going to create some sort of complexity, because this service has to be integrated with a lot of services. And to add this particular component, maybe you have to make changes on here, 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 and here. So this is one problem. And let's talk about another problem too. So today we have some sort of volume, meaning maybe we are getting 100 requests per day. But let's assume that we entered into the holiday season, and this 100 um, became like 1,000 requests per day. And now, to serve all these 1,000 requests, for sure we have to scale this particular web application. So the scaling is not that easy, because if you see here, our application are kind of microservice. I can increase the number of pods, But if you think through the dependencies what we have here, these dependencies have to be managed along with the expansion of the actual the platform. So if you think through this is some sort of platform, we have to also take care of a lot of dependencies. The expansion is not that straightforward. So these two are kind of a very, very big problem statement. So in real life, if we need to call these out, the very first one, what we talk about here, this is kind of the scalability. So the scalability is kind of the problem. And the second one is like adding another service. This is like adding few more services. This is also not that straightforward. So these two problems are kind of the day-to-day life of problems for any type of application. So to solve these problems, there is another approach that is called decoupling. So the approach, whatever we are talking about here, this is kind of a coupling architecture, meaning all these services are very tightly coupled with the one with another. So this architecture is called a coupling architecture. Since all these microservices are tightly coupled with one with the another one, we call this as the coupling architecture. So the drawbacks with the coupling architecture is like, let's say the payments are processed, but for example, this inventory service is having some sort of problems, right? Because having problems on these type of microservices kind of the day-to-day issue. But let's assume that this inventory service is running very, very slow, or maybe inventory service is having some problem. What that means is since this inventory service is having dependency with the notifications, also with the chef team, these two are not going to have the right communication, meaning since the inventory is having problem, maybe notifications are not going to deliver to the customer. Maybe chef team is not going to be informed about the inventory, so that chef team is not going to have the proper ingredients to complete the pizza thing. So the very biggest drawback with the coupling architecture is since every service is kind of dependent with some other service, the processing speed can be reduced here. Meaning here, if I have to serve the 1,000 requests, and these 1,000 requests has to go through the payment system, and then those has to go to inventory. And if I have the problem with the inventory, that means these requests will be impacted, and eventually our business maybe is going to be run very, very slow, or maybe we have to shut down our business because of this problem. So these problems are solved by the decoupling architecture. So let's take a look at what is decoupling architecture and how it looks like. Okay. Now let's assume that instead of having the coupling architecture, imagine this is some sort of middleware, middleman, maybe, or whatever we call it. And let's take the same microservices. Okay. So since we have the payments as the very first one, so whenever customers submit the request, that request will come to the payment service, and the payment service will process the payment details, and then that order information will feed to the middleman. So here, this is to maintain the order details. And this middleman is going to maintain all the updates from the payments. And then the next step should be the inventory, right? Let's assume that here we have the inventory service. And instead of inventory service is directly having connection with the payments, this inventory service is going to rely on the middleman. So whenever we have order confirmation, based on the order, the inventory service is going to take care of updating the backend inventory. And then the next one, here we have the notification. And these notifications also rely on the middleman. So based on the order details, like, for example, customer A, B, place the orders, and based on the customer details, this notification service is going to take care of the updating the notifications. And the next step should be like the chef team, and chef team is also going to rely on the this particular middleman. And here, based on the orders, the chef team is going to um, uh, uh, create the I mean chef team is going to prepare the pizzas, and once pizzas are prepared, chef team is going to update the status in the this particular middleman, this particular service right here, order service. And whenever that particular order is updated by the chef team, immediately notification team is going to take care of sending the notifications again. And then let's say chef team used more ingredients, and then those details will be updated right here. And then inventory service is going to take care of updating those ingredients as well on the inventory database. So if you see here, the biggest advantage is instead of having this complete mesh architecture right here, mesh is kind of the term. need to understand. So this is basically mesh architecture. So instead of the mesh architecture, we simplified with the decoupling architecture. So the decoupling architecture is more focusing on running all these components independently, and all the components are going to share updates with the some common service right here. And now the biggest advantage here is, let's say here I have to include another service is printing the tickets. So this ticket, earlier, if we see, if we need to include the printing service, we have to take care of a lot of dependencies, meaning we have to update few things on the payments, we have to update a few things on the inventory microservice, we have to update few things on the notification, we have to update on the chef team. But now it's a very, very straightforward. So instead of we update everywhere, we will just introduce another service called the printing tickets. And this printing tickets is going to rely on this particular middleman service. So let's say here, Jeff completed the order, then immediately printing tickets is going to take care of printing the receipt for the customer because that order is already prepared. So along with the notification, the printing ticket service is going to take care of print the receipt so that whenever customer stop by, he can pick up the pizza and also that receipt will be ready for him. So the biggest advantage here is we can add more components independent of any other component. So since this is kind of a decoupled, that means the scalability is really great. And let's say the volume also is growing up, right? So let's say instead of 100 requests, maybe if we are getting 1,000 requests per day, immediately we can scale all of our infrastructure right here. So it's matter of adding few more components because I don't have any dependencies with any other service. It's matter of adding few more resources here, and here, if this particular middleman service is not capable of handling 1,000, here maybe we can add more capacity. We will talk about that. And then here, the inventory, we can also easily expand with more replicas, or maybe we can expand the resource, the inventory. So the biggest advantage here is the scalability, and we can handle the large volumes too. Based on the volume, we can adjust the platform as required. So here, let's talk about what is this middleman. So this is the exactly the Kafka. So Kafka is nothing but this is event streaming platform, and I'm going to introduce another word here that is event platform. So it's nothing but messages. So earlier days, so we used to call events as messages, but nowadays it's a more modern acronym. So it's a basically events a streaming platform. What that means is here, whatever the details, the payments microservice is sending to particular system right here, those are more like a events. So if you see here, this is more like a event-driven architecture, right? Because basically event-driven architecture, that's forget about that word. We will talk about what is event-driven architecture. But whenever you see some message coming from some customer group, then this workflow is triggered, and then the details are coming to the this particular system right here, right? So let's assume this is the event. So whenever the events are coming to this platform, those events are going to sit right here. And based on these events, some other systems are going to process process those events. Meaning, here the events is more like order details, and based on these order details, inventory service is going to take care of doing some business logic, and then notifications is going to take care of some business logic, and chef team is going to take care of chef team microservice is going to take care of some business logic. So basically, this Kafka is handling all the events, meaning all the events are coming here, and then Jeff team is also going to send some C events, and all the events are streaming to the Kafka system. And now let's talk about what are the biggest advantages of Kafka, right? What exactly Kafka is solving that we understand. It's basically decoupling all the microservices so that all microservices can run independent of any other microservices. So Kafka is basically decoupling all these microservices. But let's also talk about what are the strong advantages of a Kafka platform. So let's talk about a few things like um, diagram. The very first thing, scalability. So the very first thing is the scalability. So here, the biggest advantage with the Kafka is the scalability. Let's say this current system is handling 100 events per day. But if my environment is, I mean, if requests are hitting like 1,000 per day, then this is more like a 10 times extra, right? So now I have to expand the cluster. And let's assume that this Kafka is running on one server today. and then expanding this into the 2 servers or 3 servers, it's a very, very straightforward. We will talk about that. So we are going to see how we are going to achieve all these things, but I just want to cover some very, very high level advantages going to the Kafka. So the very biggest advantage with the Kafka is the scalability. If you want to scale the Kafka environment without introducing any downtime, you can easily scale the environment. Meaning, if today's system is handling 100 requests, you can easily scale the same platform to handle the 1,000 requests or maybe 1 million requests. Whatever the volume is, based on that volume, we can easily scale the environment. That's the one of the biggest advantage. And the second one is throughput. So basically, if you see here, the throughput is very crucial. Earlier, if you see, all these services are kind of interdependent, right? Because these microservices, this microservice is kind of dependent on this and this. This one is also kind of dependent on this one and this microservice. And since we have to flow one event in a workflow, the throughput could be very, very low. If this guy is having some problem, then maybe the entire throughput will be going very, very down. So what is the biggest advantage of Kafka is since we have this Kafka as decoupling architecture, the throughput can be very, very high, meaning irrespective of the processing speed by the all these individual components, we can still add all those events into the Kafka platform. So that let's say if notifications microservice is running very, very slow, it can go with its own pace. And also, let's say here, if I have to add more capacity to handle the more throughput, then without disturbing the existing Kafka environment, we can add more servers to increase the throughput. So that's the kind of great advantage. And the next one is fault tolerant. Fault tolerance is one of the greatest advantages providing by the Kafka. So let's assume that so this environment right here, which set up on top of the 3 servers. Let's pick this Kafka out of that box, and let's assume that this is running on top of the 3 servers. And even though one server dead out of the Kafka, we are not going to lose any events because we have to make sure whatever the request, let's say 1,000 requests are coming per day, right? So we have to make sure all 1,000 records exist in this platform, irrespective of even something went wrong in the Kafka itself. So that's the one of the greatest advantage. We will talk about how this will happen on the Kafka when we go into the fault tolerance. I mean, when we go to the terminology and we talk about the replication factor and all that. But for now, stick with me. So one of the greatest advantages with the Kafka is the fault tolerance. Fault tolerance is nothing but even though something went wrong within the Kafka platform, this platform ensures that there is no loss on the data. Meaning, let's say if we are getting 1,000 records per day, 1,000 events per day, all those 1,000 events are going to exist in the Kafka platform. And also, this is another greatest advantage is this is supporting the real-time events streaming. So as we know, whenever the requests are coming to this Kafka environment, these events are coming in the real time. So what that means is we have to make any updates on these events. We can make all those updates in the real time so that the real time data will be available for any other microservices to process those events based on the particular designation. Meaning in the real time, whenever payments are done, that event orders event will come to the Kafka, and then whenever we have the that event updates right here, inventory process, I mean, inventory microservice is going to process that event in the real time, and then notification service is going to process that event in the real time. So basically, Kafka is supporting the event streaming in the real time. So these are the greatest advantages and some of the real life use cases, right? So far we spoke about the pizza shop and how it is working with the Kafka. But when it comes to the IT world, especially in this particular video series, we are going to cover one real life scenario that is the logging environment. So when we go to the that logging video, we are going to talk in detail, but here I will just quickly wrap what we are going to talk. So let's assume that I have a few applications will be running on different servers. Let's assume that this is application one, is application two, and this is application. And let's assume that this is generating something like 100 events. These events are basically application log messages. So let's assume that this is generating 100 events per minute, and here it is generating 200 events per minute, and here this is generating something like 500 per minute. So in total, we have around 800 events per minute, right? So in real life, what we are going to do here is here we are going to have some agents, and these are something like the producers. We will talk about what is producers in the terminology video. But let's assume that this application 1, 2, 3, these applications are configured to send all these logs to the Kafka environment. And in the real time, all these 800 messages will be leading to the Kafka, streaming to the Kafka. And here, this Kafka environment is going to distribute all those events based on how we split into the topics partitions. And again, bear with me for some more time. I will explain what is the topics and what is the partitions and all that. But for now, let's understand that all these messages are streaming into the Kafka. So once these Kafka had all these messages, on the other side, we will have some other integration, and this integration we call as consumers, and this could be something like a Logstash, and Logstash is going to read all these messages in the real time, and then it is going to drop all these messages into the Elastic. So in the real life, we call this as ELK, Elasticsearch, Logstash, and Kibana. So we are going to integrate Elasticsearch with the this Kafka platform, so that whenever we have to explore the application logging, instead of we go to the application one server, we directly go to the Kibana dashboard, and from here we can read all the application logs in the real time. So this is one of the um, real-time project. We are going to talk very in detail in one of the videos in this video course. Okay, I think that's all for this video. I hope we have a good understanding on what we spoke so far. So just to recap, in the first video, we spoke about what is the agenda of complete video course. And in this particular video, we covered introduction of the Kafka, and also we had seen one a problem statement with the pizza shop analogy. And I believe we understand what are the main advantages of Kafka. But if you like this video, don't forget to like. And the best way to appreciate this video is share this one with your friends, whoever looking for the Kafka tutorials, or maybe if they are interested in learning some sort of real life IT projects. And then this is the place. And please don't forget to subscribe to our channel. And yeah, that's all for this video, and see you in the next video. Bye.